you guys have any question between, feel free to ask me. I mean, I'm okay with stopping in between and answering some questions, or happy to answer the questions at the end. So today's topic is building AI for real world through global collaboration. And my full name is quite long, Rudradeb Mitra, but Ru is my short name. So I thought before I go into speaking about what we have been doing or what we are doing now, I thought of giving my background. So my work in AI started way back in 2002. And actually, I was lucky enough to get a scholarship from Germany in 2003 in Bremen. I was invited to come in and work on the RoboCup. That was in 2003 January. And then over the next 6 years, I worked in mostly in universities, but also startups, financial institutions. I published research papers, and that is typical AI. So not just machine learning, but on semantic web, natural language processing, expert systems. So I worked in various topics. After that, my second part of my life was mostly an entrepreneur, built a few companies. One of them was actually machine learning-based startup in Belgium. And then 2017 onwards, I call myself an educator. I spend most of my time just writing and speaking, and also mentor of various organizations, including Google, for startups. And Omdena started last year. And I think the idea came while actually traveling and speaking around the world, meeting a lot of people. So let me, before I go into the Omdena, one of the most common questions that I came across whenever I was speaking or meeting people is AI bad? And that's the most common question that I perhaps hear from people, non-technical people. Yesterday, I was speaking in a global summit on, I forgot exactly the title, is on policymakers and things, and that's the most common question that was also asked, was ethics behind AI. And I think most of us would say, like if we have technical background, we would know the answer. Yes, it depends on the technology. But there are plenty of examples out there which is a bad AI, and even built by some of the big companies. For example, Amazon ended up building something which was replicating the existing hiring process. So the problem was the existing hiring process is, of course, we can kind of say more favored towards male. So the system that they ended up building was more, let's say, sexist. Google actually built face recognition system, which was very good at recognizing males and Caucasians, because the people who are training those are the programmers themselves. So of course, that's predominantly being the programmers who are from that background. Not that they were, the intentions were not bad. I don't believe any of those programmers' intentions are bad. It's just that they often don't see the other side of the picture. And same happened, for example, in terms of when they were building a system for care to patients. And what the system was basically predicting the cost of healthcare, and it was using that to determine how good the care should be. And of course, unfortunately, in the US, African Americans who come from economically worse background, they were getting bad, let's say, the standard of care was worse. And again, because the programmers who were building the systems didn't foresee this kind of the bad sides of those systems. So, and I think that actually causes one of the biggest problem in AI, machine learning, or data science. I mean, I'm bringing them all together under the same umbrella of AI. And we can, of course, say that, okay, data science and AI is different. But basically, when you look at the world, in the real world, actually 87% of data science projects never make it to the production level. And I think a lot of that problems is because of this kind of systems being built in silo. Programmers writing a piece of code, kind of building something, a proof of concept, but never making it to the world because of ethical bias issues, but also a ton of other issues. And so that comes to this, when going through all of that, and the first thought that came to my mind was, I think that one of the way to deal with this kind of, let's say, the biases or the bad AI is to build the solution collaboratively, engaging people from all over the world, different backgrounds, culture, ethnicity, sexes, ideas, viewpoints. So that was the idea, that can we actually bring people from all over the world who could actually together collaboratively build some solutions together. And what would that do is, of course, that would bring the diversity of opinions and bridge the gaps of understanding different cultures. And that's the basic idea. And that's what Omdena is all about. What we have achieved over the last 12 months is over 950 people from 80 countries actually have collaborated on 18 such, we call them projects or challenges. And these people are not only people from, let's say, students. The age group is from 16 till, I think the oldest we have was 65 or 70. Almost 30 to 40% of our participants are female. Most of them, if not all of them, have actually being educated through online courses. But we also have people from Google, MIT, Stanford. So we have this range of people from really different backgrounds and skill set coming together and building something. And we have worked with organizations like World Food Program, United Nations High Commission on Refugees, World Resource Institute, but also we have worked with startups, we have worked with businesses. And in today's talk, I will show you some of those, some of the work that we had done. So I will start with one of the first project that we did, and actually that created the whole idea behind Omdena was basically a startup. I was speaking in India, and a startup came to me and said they would like to use AI, or let's say to help solar power adoption. And what is the problem they were saying is that it's not only in India but around the world, was that if someone wants to adopt solar power in their rooftop, the process is that they have to ask someone to come to their home, who goes to the roof, measures the roof, and then after a week or so sends a report. The report will contain that, okay, this many solar power cells you can put in your roof, and this is the kind of energy that you will save every year, which all of us can agree that it's kind of really old-fashioned, and that really hinders the adoption. So the guy said that, can we use AI or machine learning, where this process of understanding how much is the potential of my roof in terms of solar power can be automatized, basically. And so that's what the challenge was. There was already at that time some projects, including from a Google called Sunroof. And when we analyzed Sunroof, and I actually also spoke with the head of Sunroof project, we saw that their project worked, the solution works only in high resolution images, which is, most of the world doesn't have the high resolution images. So you can see in this one, in the left-hand side is actually a picture of a rooftop from Delhi in India. And you can see the resolution of this image is really low quality. And even for humans, just to make it out that this is the roof and there are some obstacles was quite difficult. So we ended up building the solution. We used different algorithms like masked CNN and UNIT. I will not go in details. And you can see that when we build this solution, to the right-hand side, you can see that how the machine was able to identify the rooftop areas. And it was quite accurate. You can see it's almost a 95 to 97, 98% accurate. Similarly, is another picture here you can see. And here also, you can see, in fact, the machine was able to even distinguish between two of the same building, different kind of heights of the roof, which was, again, super interesting. And the end result that the startup wanted to build was something like where someone comes in, types the address, the machine finds the address, scans the roof, identifies the area of the roof, but there are also identifies the obstacles in the roof, like mumties and solar, mumties are, for example, water tanks. And then based on that, says that this is the area if you analyze the solar power, and this is the energy that you will save. So all of that could be done in a very short time, within less than a few seconds, and that can definitely help to adopt the solar power. So that is one of the first the work that we did, again, collaboratively, where I think around 50 to 60, mostly students from India, came together and built the solution. The second work that we did, what I want to give an example, was on how do we use AI fighting forest fire. And this was a Brazilian company. They already have existing cameras around Brazil, and they are using non-machine learning algorithms. So they are using image analysis, simple ones, and they have a lot of false positives. which means that in many cases, when there is no fire or there is no smoke, it was identifying that as a smoke. And that's actually quite difficult, because in these cases, if on a remote place there's a camera which identifies this to be a smoke, which actually is not, then they have to send someone perhaps to go and inspect that, which is expensive. So the guys said that, can we build something which could be actually identified, help to detect the smoke, and we build a CNN model. Here also, I think we use deep UNet. And of course, there was the first part was labeling the image. We labeled the image, we identified the difference, what is the smoke, what is the cloud, what is the fog. If it was a human labeling process, we labeled around a few thousand, or I think 5,000 to 6,000 images. And at the end, we were able to build a model which was around 90, on the validation set, around 95 to 97% accurate. And now they are integrating the solution into their existing, the model into the existing solution. The third case that I want to talk about was on how did we are using AI to help fight conflicts. And this is a project that came from United Nations High Commission of Refugees, UNHCR. And what was the requirement was that they wanted to understand that whether there is any correlation between climate anomalies and conflicts in Somalia. And so climate anomalies would be typically say droughts. So in Somalia, often droughts hit, and they see certain levels of, let's say, conflicts happening. So what we did is we first of all tried to get data, understood there is something called vegetation index. So we mapped the vegetation index over the last, say, 10, 15 years. And as you can see that, the vegetation index varies from 2005 to 15, this kind of over a period of time. And then we took different regions of Somalia, and we analyzed whether there is any correlation between the deaths happening during conflicts and the vegetation index. So this is just one of the graphs of what we mapped. And you can see clearly that whenever the vegetation index is low, within a certain period of time, there's a high spike in the number of deaths. And when there is a region which is high vegetation index, so the blue curve is actually represents the vegetation index, there is a period which is completely peaceful and almost no deaths. Now, how is that useful? Because through knowing, and we use through satellite images, by knowing that the vegetation index is going down, or kind of knowing that, okay, there is a chance that a drought is happening, we can potentially predict potential conflicts in certain parts of the Somalia, because it doesn't often happen that where the drought happens, conflict happens exactly there, because there's a migration, and then followed by migration, there is a conflict. So if we were able to map that there was a correlation between the lowering of the vegetation index and the conflicts within a certain period of time, and also where the conflicts happen, so we are able to predict and avoid potentially conflicts in Somalia and help and save lives, actually. Another work that we did was with an organization based in Chicago, and what they were trying to do is fight gang violence. And what they came to and said that, look, gangs, what they have observed, that gangs are often using abusive, violent language in Twitter, and they're kind of abusing each other, and they want to see if there is any correlation between Twitter use, or using violent words in Twitter, and actual violence in the real world. So, but the gangs don't use plain English, so they have their own language. So we were able to get a lot of this kind of crypted gang language, also I guess from the FBI, and they use a lot of signs, symbols, terms that is not understandable to us. So first part of that was, of course, building a language understanding of the gang language. And then what we did is we tried to see if there is a correlation between the crimes that's happening and the mention of, let's say, a gun in a threatening tweet. And when we see that in the same day, we didn't see much correlation. But as we made a shift, and we saw that with a 2-day shift, there is a clear correlation, which means that gangs are actually, let's say, using this word of threatening tweets online, and after 2 days, there's actually cause of a crime happening. which is also makes sense that you're trying to first of all abuse each other and kind of thing, and then it escalates to a point, and then you go and do the actions. So of course this is very useful, because then potentially crimes could be stopped by understanding this kind of behaviors online. And not only that, what we were also able to do was we were able to do a network analysis. So we were able to understand, since gangs also work, there are different regions of the gangs as gangs work. We were able to understand which gang is speaking what. And once we know that, we were able to kind of potentially say, okay, these are the gangs that we should be careful about, or look at these are the gangs that potentially can cause the problem. Another topic that I want to talk about was that how did we use AI to help disaster planning? And this was the work that we did with, this is the work that we did with, I'm sorry, I was just looking, there were some messages, so I just got distracted. With Impact Hub in Istanbul and I think UNDP actually, yes. So what was the problem that they said was that one of the things that they realized, that, as you know, earthquake is a big problem in Istanbul and in general in Turkey, that we don't want to predict earthquakes. When that was not the problem. The problem was that once an earthquake hits, the first thing that people think of is reaching to the loved ones, whether to go to a school or to pick up the children, or going to their parents, or to their wife or husband or whatever. Like, that's the first thought that comes to their mind. And they said, can we build a model that can help find, let's say, the safe route to reach from point A to point B? There was no data about that. So what we did is we thought, okay, maybe our way to solve this problem is, let's pick up the most popular and the crowded district of Istanbul, which is Faith. And we we initially thought we'll use the data from the road, the width of the road, and kind of understand if there are wider roads, then they most likely will be more open than the narrower roads after an earthquake. But we couldn't find the data because OpenStreetMap had the kind of missing data and kind of incomplete data. So instead of using the existing data that was incomplete and often wrong, we use satellite images. So from satellite images, we were able to identify the rooftop buildings. And it helped us to also not only map the buildings, but also the roads, but also the open areas. So parks and things that are not necessarily buildings, which can remain open. People can just walk through that. And that was so interesting, because if we had followed the OpenStreetMap, we would have only got the width of the road. And then based on this was the first output, and based on that, we kind of created a heat map of less dense area. And on that, we built the route planning algorithm. And as you can see, this was just an output from, so if you can see, there was an input and output, the from and the to. The blue color is the map, that's the path that the Google Maps gave, while the yellow one is the one which was our algorithm gave. And as you can see, that this was kind of bypassing from the more dense part of the city and kind of going through the parts which are less dense. Interestingly, the work that we did was picked up by the Next Web, and they wrote an article about this. What we did was that it could help reunite families after an earthquake. So feel free to go and read the article. And although we were not aware of that they are writing this article, but it just one day popped up, and someone said to me, "Hey, did you read the article that came out about you guys, what you did in the Next Web?" So that was quite an interesting thing. And we are also now currently working with the World Food Program. And one of the biggest challenges of World Food Program is disaster response. And this is, again, similar to idea like the earthquake. But in here, we want to plan as what kind of goods and some things to provide when a disaster hits. So perhaps some of you know, World Food Program is the world's biggest, the biggest UN body. I think over 10,000 people work in the World Food Program. And one of the part of things what they do is they go and give disaster relief in these remote parts of the world, in terms of not only food, but also in terms of sometimes direct cash and other materials. And one of this biggest problem they face is that they don't know how much supply to send when a disaster hits in certain area. So we are finishing the work this week, and we will present the work next week. So if someone wants to be part of it, feel free to join, and we will be happy to kind of, share those. You can come and listen to the work that the community have done to build the model. on this solution. And the final topic that I want to talk about is one of the key areas that we've worked on is data-driven policymaking, which is actually very close to me given the current moments we are in. So we did multiple projects on that, so I will pick up only, I think, 2 of those. One of them was in India, and what the goal was, it was with the organization called World Resource Institute, which is based in London. And what they said, one of the challenges that they face, that governments around the world almost have no idea about where are the land conflicts happening and what causes the land conflicts. So what we did is we first of all, of course, scrapped newspapers. We got a lot of data and tried to, through topic modeling, try to understand what are happening, where are those people dying, what are the causes of land conflicts, and then mapped that in India. And based on the topics, we tried to also connect that to different policies that might be causing the conflicts, because often if you're scrapping the news article, you would be also able to, the reporters will also be talking about this caused this thing, or this is the cause, this is the policy, or this is the reason that this is happening. So we're trying to at least have policymakers understand that what are the causes of this kind of land conflicts is happening. And again, if you want to go and read this, the work that we did, again, it's not a full technical report, but at the high level, this article was written by UN Convention to Combat Desertification, UNCCD actually it's called. And there they write about how and what we built was connecting land conflicts and policies and understanding the effects of that. And one of the projects that we are running now is given the pandemic that we're facing, and different countries, as you are aware of, are applying lockdowns and different kinds of policies they have. And one of the things that we want to understand is how is these policies are affecting the most vulnerable population. And here I use the economically marginalized, but we actually, when we broadened it up to be vulnerable population. So we got over 75 people from, I think, 29 countries, including experts from different organizations. And I think people who have worked in Ebola crisis, who understands crisis management, who understands from healthcare, from policymaking, from people who have dealt with pandemics, and then around 50 to 60 data science and AI engineers. And this is currently ongoing work, so I cannot really share all the details that is being done, but I can just give you a few experts of what is being done. Is that what we first identified who are the vulnerable population in the world, which was actually quite a difficult thing to do because it's not so simple that identifying a vulnerable population. But we came to 4 metrics. It's like people who have losing access to healthcare, people who are losing wage, people who have lost employment, and people who are facing domestic violence. And there's a difference between wage loss and employment loss, just to be clear, to make it clear that there's a lot of people, let's say in countries like in Asia, in India or Africa, which is work in the informal sector. So these are never losing employment by official records of employment because they are never employed anywhere because they work in the informal sector, but they are losing wage because they are daily wage workers. So that's the difference between wage loss and employment loss. And then we try to, our goal is to build that, look at map of certain policies and map that to say correlated to one of those vulnerable population and how is that affecting. To give an example, this is just a graph where we try to look at Google mobility index versus Google search index on domestic violence. And we are comparing, let's say, Sweden to Belgium. As you know, Sweden has been more relaxed in terms of lockdowns. Belgium or other countries have not been. Even we had a graph from Germany. I don't know why I didn't put the ones from Germany. Because Belgium and Sweden are kind of comparable in size. That's why I remember. Anyway, German graph is the same as in Belgium, just to make it clear that, as you can see, the moment there was a mobility loss, which means that the workplace were closing and the schools are closing, there's a huge spike in people searching for domestic violence. While in Sweden, it didn't happen. You can see the graph is about domestic violence is quite steady. So this is just one of the metrics with looking at what is the effect of domestic violence in terms of lockdowns. But we will be also looking at the other metrics, and I think we'll finish this work in 3 weeks' time from now, and we'll present the work around in a month from now. But we had got a lot of interest from the work that we are already doing. We already got attention from media. This article came out in IEEE Spectrum, where you can, if you want to go, you can read about it. It's how are we lockdowns affecting the most vulnerable. We kind of go explain certain things. And we were also been quite lucky that our work was covered or highlighted by NASDAQ and Nordscan Foundation in the NASDAQ digital billboard in Newark. And that's some of the work I gave you example of work that we have been doing or we did in the last 12 months, but there are of course a lot more which I couldn't go in details. But we also want to show that there are a lot of interesting problems that we are going to work in the next coming weeks to month. They are not in the website yet, but we are already talking about one on waste management. Just got an email from someone. We might work on tracking waste and how the places which are dealing with the waste and look at some data points on that. We also want to look at the domestic violence case, one more in India, specifically in India. We are also looking at one with our organization called Botnard Foundation, which we are trying to look at how the youth population thinks and what are the aspirations are. Currently, we are working one with Arizona State University on understanding the student debt crisis and how it is affecting students. So these are the range of different topics that we are now working and we have in pipeline. So if any one of you are interested to be part of upcoming work projects, feel free to go and apply to that. There are only 4 and 5 questions that we ask. Now, that's all of that is being done and the work is being done, but I also think that the best way for the work that we did is to let the people that actually that we had worked with to speak about. So there are, on one side there are these organizations that we have worked with. So for example, the Brazil wildfire detection I don't call it a startup, it was actually already 5-6 years old company, but what the guy has, Osmar, who is the head of innovation, that the work that we did was, has been extremely useful for them. And they're already incorporating that into existing solution. And for them, Omdena is official AI partner. So was a very nice feedback to get. Or from Rebecca, who was in the UNHCR, see that what they experienced was this diversity and the background of ideas that people come in and work and build those solutions. Or Semi, who is a co-founder of Impact Hub in Istanbul, the work that we did with route planning, he said that it was the best idea that he saw, or the best thing he saw in 2019. And there are many more feedback that we got. But that's one side of it, that we're organizations that we're working, we're building the models for what they have to say. But on the other hand side, also these people that are coming from all over the world, it's 900 plus people coming together and collaborating, what their experience have been. And this is just some of those experiences. Of course, I cannot bring all of them, but just give you some ideas. Yemisi is from Benin, and she said that what really helped her was to overcome her own feelings of not being smart enough and build a career in AI. Because when you're working with other people, a group of people, you are basically, they are helping each other, you're working together collaboratively, and kind of also overcome your own insecurities and sometimes imposter syndromes. Anastas is from Greece. Actually, what he said that what his biggest experience was to realize the generation's potential, that we start with absolutely no data and we end up building some interesting models. On almost all the projects that we said, we don't start with almost any data. In fact, only the Brazilian was where we had some data, but the rest is all open source data that we deal with. And that's very useful. That's very interesting for us to hear this. For example, Rosanna, who is working in the World Food Program that we'll be launching, will be finishing this week and showing the results next week. She's a postdoc in, I think, Frankfurt Advanced Studies Institute. And what she wrote that what she learned in the last 2 months was more than the last years combined. Again, for us, it's super interesting to hear that kind of feedback. But what we also give to them is when they finish a particular project, we also give them certificates. We also give them access, not only the community, they get to actually get of course they get the experience, but they also get certificates, but they also get a community back and the access to tools that we are trying to create an ecosystem. We have partners like Spell, Labelbox. Normally these tools cost hundreds, if not thousands of dollars. But we also have courses, partnership with DataQuest, who are giving them courses. So we are trying to build an ecosystem from the side of them. and which is very important, I think, for these people to kind of not only show to the world that they are doing something interesting, learning something, but also growing in the career. That's Soros. He's from Iran, and he kind of just writing about his certificate. And another great news that, of course, as they grow up, this is Anita. She actually lives in Berlin, and to move in the career to the next level, get a job, and she recently got a job, and what she says that, in her words, that to get a boost in her confidence and get a job, which is a great success for us, I think, at the end of the day, both on the side that we're building interesting solutions, but also that people are getting jobs and moving up in the career. So finally, before I end, I think this is one of the nicest quote that I want to say, which is written by Samir. He's actually now works in Google, and he was one of the first participants, one of the first challenge that we had worked on. And what he wrote is basically saying that a group of strangers from different corners of Earth who have never met each other before, transcending geographical borders and time zones to work together and solve fascinating social problems, whilst learning from each other and inspiring each other every single day. This isn't just a figment of my imagination. Such a world exists, and I'm extremely grateful to be part of such an extraordinary journey. And to me, that actually, in essence, truly captures what we are doing. I truly believe that the future of what we are building is a bottom-up, where people coming together, collaborating, solving problems that they face with a high intrinsic motivation, without relying on governments and corporates to come and solve our problems. Technology and education and access to internet has given us that opportunity, and we just have to utilize that. Few days ago, I actually wrote a couple of articles which I haven't put my comments. One is I compared that a lot of you know about Kaggle, and I compared that also with hackathons. There's a lot of hackathons being happening, and a lot of people, of course, Kaggle. And I compared what we are doing with both Kaggle and hackathons. And my logic is always saying, why are we competing with each other? Why do we need to be on the top of a leaderboard? Why are we in hackathons coming together and kind of competing? Why can't we just collaborate? Why can't we just come together? Not the more experts help the people less expert to become more experts, and together solving a problem. And that's the future that I and we in Omdena believe in, and that's what we have been doing. So that's where I end my talk. Thanks for listening. I will be very happy to look at some of the questions or answer, or if you have any questions, feel free to ask me. That's my LinkedIn. Feel free to follow us in LinkedIn, Facebook, Twitter, or Instagram. Thanks a lot.